So multiplication theorem and a probability. Multiplication theorem is nothing but simply whenever you are taking the two events associated with any sample space, let us consider the two events E and F associated with the sample space S. The set E intersection F denotes that event that both E and F have occurred. That is, suppose whenever you consider the E intersection F, E intersection F denotes that both A and E and F are occurred. So, in other words, in a simple way, E intersection F will be written as E F together. Just multiplication, just like a multiplication, we will write it. So, you know that conditional probability says to you that whenever you are taking into consider, probability of E given F is equals to probability of E intersection F by probability of F. So, from this, whenever you are taking into consider, so from this you can write that probability of E intersection F can be written as probability of E intersection F can be written as A multiplied. So probability of E given F into probability of F. And you can write probability of F into probability of usually will be written as so probability of F, probability of E given F. F occurred already. So probability of F given E can be written as probability of F intersection E by probability of E. So this implies in this case probability of F intersection E or E intersection F, both are same. E intersection F or F intersection. So probability of F intersection E can be written as probability of E into probability of F given E. F given E. So these two, whenever you are taking into consider, will be considered as a multiplication theorem and a probability. So that is nothing but if you want to sorry. Okay, this is called as multiplication theorem and a probability, multiplication rule you can say. And this can be applied for the not only the two events. Usually, three events whenever you are taking into consider or four events whenever you are taking into consider also can be applied. So probability of three events whenever you are taking, probability of E intersection F intersection G is equals to, see here, probability of E into probability of, already we have did this just like a, when you are doing the multiplication. In case of the multiplication rule in combinations and combinations, before starting combinations and combinations, we are going to apply it. So, but here in case of the probability, we are going to do it. Probability of F given E, probability of E into probability of F given E into probability of G given E intersection F. Probability of G given E intersection F. So like this, if you are taking three events E, F, G, so the multiplication theorem can be, if you want you can write this as if in E intersection F can be written as just directly probability of E into probability of F given E into probability of G given E F. Three events. If you want four events, suppose A, B, C, D events you are taken into consider. So probability of A intersection B intersection C intersection D, C intersection D, if it is taken in. This is not given in your textbook, but you can apply it. So this is equals to, whenever you are taking probability of first A into probability of B given A, probability of B given A, in a reverse order, B given A into probability of C given B A intersection C given A intersection B. So AB should be the probability of D given A intersection B intersection C. Probability of D given A intersection B intersection C can be written as directly I already told you here. E intersection F can be written as EF. So in the same way, probability of E given A B C. So 4 events whenever it is taken, 5 events whenever it is given to you, you can extend it like this. So now the next concept is independent events. 2 events A and B are said to be independent events. Normally the word itself you are having the independent, so not dependent. So one event is not dependent on other event. So effect of means here probability of occurring the one event is not dependent on the probability of occurring another event that we are taking. Then the two events are said to be independent events. But independent events, original definition most of the students don't know. Independent events. 2 events E and F. Two events E and F are said to be independent events. Original definition is mostly people will remember that E intersection F is equals to property of A into property of F. That's not the original definition of the. That is a means. If you are see here, probability of F given E, F given E, given A is nothing but A already is occurred. So that is the occurring of event E is not affecting the occurring of event F. It is not affecting. So that when do we say that not affecting? So this is equals to probability of F. Probability of F given E is equal to probability of F. If it is provided that probability of E is not equal to 0 and probability of E given F, E given F is say E given F is nothing but given F. So F is occurred already and E is occurring. So the occurring of E is not affecting and probability of F is not equal to 0. So whenever, if these two are satisfying, then we can say that the E and F events are independent. But in both the cases, whenever you observe that probability of E, F given E can be written as F intersection E by probability of E, which is equals to probability of F. The A interlinkage also probability of F intersection E is equals to probability of E into the probability of F. You are going to get it. So if the events are like this, then we can call that actually the two events are independent events. So probability of E given F can be written as probability of E intersection F by probability of F, which is equals to probability of E. Those two multipliers, what do you get here? Probability of E intersection F is equals to probability of E into probability. In both the cases, you are going to get probability of E intersection F is equal to probability. That is nothing but if you verify that the intersection of the two events, probability of intersection of the two events is equal to probability of E into probability of B, then you can say that two events E and F are independent events. And please do remember that independent events is completely different from the mutually exclusive events. Mutually exclusive events is nothing but if intersection part is equals to 0. Probability of E intersection F is equals to 0. If there is no intersection, then they are called as mutually exclusive events. There is a lot of difference between the mutually exclusive and independent events. So there is our problem in your exercise also whenever you are taking into consideration. So let us enter into the exercise problems here. Okay, so ये इंडिपेंडेंट इवेंट समझ में आया ना? नॉर्मल डेफिनेशन इज दिस वन, probability of f given E is equal to probability of f, that is nothing but probability occurring of the event f is not affecting the occurring of event f is not occurring the affecting the occurring of event E, that is nothing but probability of E interest E given f is equal to probability of E we are saying. So that is nothing but f occurrence is not affected because both probabilities are equal here. So in that situation, you can consider that the both situations, if it is taken into consider, then the two events are said to be independent events. Okay. So let us move to the exercise problems given to you based on the multiplication theorem. Very simple questions are there, not very complicated, except 2-3 questions remaining all are very simple here. And let us complete the multiplication theorem and independent events problem based on this exercise 13.2. The first question is given to you, probability of A is equal to 3 by 5. Probability of A is equals to, first question, 3 by 5. Probability of B is equals to 1 by 5. Find the probability of A intersection B if A and B are independent events. So A and B are independent events, is nothing but probability of A intersection B is equals to probability of A into probability of B. Probability of A is 3 by 5. Probability of B is 1 by 5. So which is equals to 3 by 25. As A and B are two independent. Second question is, two cards are drawn from the pack of the deck of the cards randomly without replacements from the pack of 52 playing cards. Find the probability both the cards are black. So here A is an event, and E and F also you can consider. It's not mandatory that A only to be taken into consider. So A is the event that first drawn card is black. The question is given that find the probability both the cards are black. So that is, and B is an event that second drawn card is also black without replacing first card. So what we have to find out here, probability of both the cards are black. So both the cards means first card is black, second card is also black. So that can be represented in what way here? So probability of A, first card drawn out of 25 black cards. How many black cards will be there? Out of 25, how many black cards drawn? Out of 52, how many black cards will be there in a deck of cards? 26 now. 26 black cards will be there. So 26 out of the, so probability of A is equals to 26 by 52. That is nothing but 1 by 2. Okay. That means event A is already occurred and it is not replaced again. So now what we have to do? Second draw card is black. Second card, drawn card is black. That is represented by probability of elements. We need to find out probability of A into B. AB means A intersection B. So B already A is occurred. So A is occurred is nothing but black card is drawn, but it is not replaced again. So there are 25 black cards and there are total 51 cards. So 25 by 51 is the probability of B intersection. And we need to find out probability. Last we have to write here. Probability. What is question asking? Probability that both the cards are black. That both cards are. This is represented by what? You know, any one of you? That representation is also you need to know. AB. It is represented by AB as per the other consideration. So probability of multiplication theorem whenever you are using. Probability of A intersection, probability of A intersection F, A intersection B only this is. So multiplication theorem whenever you are using. AB is asking you. So A intersection B is asking. Probability of what do you get here? A into probability of B given A. Here probability of E intersection F is equals to probability of E into probability of F given E. E into F given E. A into B given E. Which is equals to probability of A is 1 by 2 multiplication theorem 25 by 51. So which is equals to 25 by 102 here. See, simple here we are going to find out that probability and we are going to multiply them. But the representation you need to know properly. Suppose third question is here. A box of oranges is inspected by examining the 3 randomly selected oranges without replacements. And if all the 3 oranges are good, then the box is approved for the sale. So 3 selected oranges. So 3 are good oranges, then it is approved for the sale. So find the probability that the box containing the 15 oranges out of 12 are good and 3 are bad. 12 are good, total 15 are there, 12 are good and 3 are bad ones. Will be approved for the sale. So will be approved for the sale means probability of A is nothing but first drawn orange is good. Second B is nothing but second drawn orange is good. C is nothing but probability of third drawn orange is good. And without replacements. First one orange is drawn. And here it is not replaced again back. And it is found as a good. So probability of A. A is an event that first drawn orange is good. So total good oranges kitna hai 12. 12 out of 15. So next B is an event that second drawn orange is good. And A is occurred. So probability given A. So one is already taken out. So 11 out of 14. And probability of C given AB. So AB is already occurred. A and B are occurred. So 10 out of 30. ये तीनों को multiply करना है. We need to find out probability of A, B, C. Actually, we need to find out probability of A intersection B intersection C. 3 events means 3 times good oranges only we got it. So that is represented by 12 by 50 multiplication theorem of 3 events whenever you are taking 12 by 50 into 11 by 14 into 10 by 30. So representation is very much important. This most of the students will don't know. They are going to you people will write this multiply karna hai, but representation. A is an event of drawing the first drawn orange is good. B is an event of drawing the second drawn orange is good. C is an event of drawing the third drawn orange is good. And then after this 12 by 15 is represented by property of A. And 11 by 14 is represented by property of B intersection A. And property of C intersection AB is nothing but 2 oranges are drawn, third drawn oranges already occurred, these 2 are occurred. And third drawn oranges, even with the replacements also, we have to represent like this. With the replacement is nothing but already replaced. Every time we are going to get 12 by 15. 12 by 15, 12 by 15, 12 by 15. But the question is given to you without replacement. So all the problems are mostly like this only. You can solve it. It's not very difficult. Fourth question, if you say take that, fair coin is An unbiased die is tossed. See here. A fake coin and unbiased die tossed. A is an event that head appears on the coin. So first, what is the sample space? That is right here. Can anyone say the what will be the sample space? A die, a coin is tossed and a die is unbiased die is thrown. Coin tossed is nothing but head and tail we are getting. Next after one unbiased die is thrown. Die means 1, 2, 3, 4, 5. So you are going to get head comma 1, head comma 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. Okay? This is sample space. A is an event that head appears on the coin. Head appears on the coin means A is nothing but this is an event. H comma 1 head appears and H comma 6. And B is an event that 3 on a die. So B is an event that 3 on a die. 3 on a die is nothing but H comma 3, T comma 3. Two events here. And the question is asking to you whether A and B are independent events or not. A and B are independent. So independent events के लिए क्या करना है? A intersection B find out. So what is A intersection B? Is there any intersection here? Is there any intersection? Yes. H comma 3 you are going to get in the intersection. Okay. So what is probability of A intersection B? Sorry. Can you say? A intersection B. 1 out of 12. So 1 by 12. So what is probability of A? Here 6. 6 by 12. That is nothing but 1 by 12. What is probability of B? 2 by 12. That is nothing but 1 by 6. So what you get probability of A intersection B is equals to 1 by 12. Probability of A is 1 by 2. So we are creating probability of A into probability of B. Therefore, you can say that A and B are independent events. We can say that independent events in another way. Actually, original definition, if you are reading it, original definition is what probability of A given B is equals to probability of A. If probability of means occurring of B is not affecting the occurring of A. Probability. Sorry. Probability of A given B is equals to probability of A. Probability of A given B means इसमें A sample space consider. Then what is it? You are going to get it probability. Sorry,